So I'm living proof that you can found a tech company without having dropped out of school. So we founded Vivid Cortex about 1.5 years ago, or venture-backed, and we do database performance management. So if you know what application performance management tools like New Relic and AppDynamics do in the application, we do that in the database, and we do it for MySQL at the moment. We have a bunch of code that we've written and has been useful for us. It's on our GitHub repository. Hope some of that is useful to some of you. Please contact me. I love hearing from people. Also love meeting people. It's one of the great things about conferences like this. Here's a couple of other, I'm going to upload these slides, but I just wanted to mention a couple of other resources that are good for learning about how to work with Go's database SQL package. Of course, the documentation is one. We've written a tutorial. There's kind of a lot of, as with any source-based documentation, telling a story in source-based documentation is hard, but a lot of times helping people to understand how to use something really needs to be kind of a narrative rather than here's something and here's what it does, here's something else and here's what it does. So our GoDatabaseSQL.org tutorial, it started out as just a README file on GitHub repository, and it's turned into a website with a whole bunch of people contributing a lot of important and useful information there. And in particular, the two guys who write the MySQL driver that I mentioned on this last link have contributed a lot there. And a lot of it comes from things like repeated bug reports about the driver and so forth. So there's a lot of sort of common gotchas that you can avoid if you read that. And it is a narrative, and I'll cover a lot of that material today. So there's things. It's just a picture, just because. I don't even know why this meme is funny to me. It's just funny. I still cannot explain this one. When I first looked at database SQL, my initial thought was, oh my God, they just reinvented all the bad things about every other bad database interface library I've ever seen. This is horrible. I had written a couple of them myself, and they were, frankly, the ones that I was the most comfortable with and thought were the best designed looked a lot like the ones that are in, let's say, in Microsoft's class libraries and so forth. I spent a few years at an all-Microsoft company, and I thought that that was the best and the cleanest abstraction of a database. And so there were a whole bunch of things here that just looked wrong to me. And this is after coming from many years as a Perl programmer where you had a DBH, which was a database handle, and then you had STHs, which are a statement handle. And that never felt right to me, either as a programming abstraction or as an abstraction of what's an accurate representation of the model of the things that you're actually working with. And so I looked at this, and it was like, oh, here they've reinvented it again all over, wrong. And I'm happy to report that I was wrong, and that I think this was mostly Brad Fitzpatrick's contribution to the standard library. I think this is I now believe that this is a cleaner and simpler and more minimal abstraction of how to interact with a database than I was hoping for. So you have this thing called a DB, and a DB, it's important to note, is not a connection. A DB represents your database, whatever that may be. It may be a database server somewhere. It may be something in memory or a library or something like that. It could even be something that you've mocked. But it is not a connection to a database. And I guess this probably took me a couple of weeks to figure out, because I'm a little bit dense that way. And there's only a few things that you can do. So one of the nice things about this is that there's not a lot of nouns and there's not a lot of verbs. And in fact, many of the verbs are consistent between a couple of the different nouns. So it feels like you're doing exactly the same thing, even though the concrete types that you're operating on may be different. So you open a DB to create a DB, not to connect to a DB. And you can close it when you're done with it. And you can do things like querying and query row and exec on it. And another of the major concrete types that you'll spend a lot of time working with is rows. And a row is not, as I have been accustomed to thinking about it, some kind of like a hash map or an array or something. In fact, it is an abstraction over a cursor. And you can next to ask your cursor to go to and fetch a row of data from the database itself. and you can scan that into variables. So my talk is done now. You're welcome. So there's a few. The question is now with this kind of minimalistic interface, how do you interact with it? And just show of hands, who actually uses database SQL? So like maybe 40%, 50% of us use database SQL. So I just want to cover some kind of patterns that I have learned over the year and a half or so that I've been working with this. So here's a complete little Hello World program, and it illustrates everything that you need to know to create a DB, and then you'll be ready to start using it. This is actually compilable. Everything else that I'll show you today is just snippets, but this is kind of the framework that all of those snippets should fit into. So the first thing that we import is going to be the driver. The database SQL package requires a driver, which is database specific for how it actually interacts with the database. And because I'm not actually going to use that driver in my program, I have to underscore it so I don't get an unused import error. And then I mention it in the SQL.open as the first parameter, in quotes, as a string. So that's the name of the package that this database object, this DB object, should use to connect to its actual concrete implementation. And in this case, and then there's a second parameter, which is the instructions about how the driver should connect to the database itself. In this case, it's what's called a DSN, data source name syntax. It's user and password and host and so forth and so on. SQL.open does nothing except pass that on to the driver, and you generally won't get any error. So I have this commented outline. What do we have here? At the line where that comment is, we do not have a connection to the database because you haven't done anything with the database yet. You have a DB object that is ready for you to issue queries against, and DB handles connections for you, creates and destroys connections and so forth for you automatically. It removes a ton of what's otherwise a lot of busy work. And then idiomatic database SQL would be idiomatic Go. So if you create something that's expensive and you expect to have to tear it down later, you're going to defer. So defer db.close. In this case, it's the last line in the function, so it's a little bit silly to have it here in this example, but that's important to note. Now, a DB is not meant to be opened in one function and closed in that function and then opened in another function and closed again. DB is meant to be something that is essentially global for the life of your program, and that DB should be long-lived. And the reason for that is, as I'll mention later, that this package actually manages a connection pool for you. So if you're creating and destroying DBs a lot, you are going to be creating and destroying lots and lots of connections to your database. So now we're in the realm of snippets, and assuming that we've embedded this into a function like main on the previous slide, you can do things like query a row from that database. There's only a few sort of functions that you'll end up using over and over again. Query row is when you expect your statement to return one and only one, or at least a maximum of one row from the database. And then you'll see that db.queryRow is returning a row object, which has a method called scan. So I'm scanning and passing a pointer into a string. Now that scan operation is going to copy the column out of that row into my string. So this kind of reveals how concerned Go is with the memory allocation here. We are not dealing with something that kind of abstracts away all of these details. As usual, the explicitness of creating and destroying and allocating memory is very obvious to us here. Idiomatically, after everything that you do, like in most of Go, anything that could possibly go wrong, you will check for an error after it. And query row has a special case error that can be returned only from query row and not from any other place in the database SQL package, which is this error no rows. If that query returns 0 rows, then you'll get error no rows, which is a signal to you that your variable stir did not get a value copied into it. So if you're using query row, you may want, depending on what your code is doing, you may want to handle SQL.error no rows specially. I didn't understand this at first. I didn't understand, even though the documentation says it. I didn't understand that this error could only come from this function, and so there's I think there may even be a couple of places in a large code base that we have where I had written some error no rows handling in places where it was an impossible error to have encountered. So we've seen how to query a single row out of the database. That's kind of your one-shot, one-and-done sort of thing. Most of the other types of use patterns that you'll see are a little bit more complicated. There's just a little bit more kind of handling to be done. Side note, I think I've not used the MongoDB and Go together. And when I was watching the presentation earlier today, I just kept thinking, how clean, how elegant. I want to design something. We can't design it within database SQL. And I know lots of people have designed sort of ORM-ish types of things on top of database SQL, but I think that a package such as database SQL could be struct aware. I'm kind of noodling on some of those thoughts now and make that a lot cleaner. In any case, back to regularly scheduled programming, we have a string that represents our query, and here you can see I have a question mark placeholder in it. So you should parameterize your statements, and this is sort of SQL basics. Protect yourself against SQL injection attacks and check your inputs. Do not concatenate strings together. So you should use question mark parameters for that. And when you do, the driver can be told to prepare a statement and then use a value as a parameter to that statement. Drivers can also optionally, if you don't pass a parameter and the driver supports it. So if your query, as on my previous slide, has everything embedded within it and there's no question mark placeholders and there are no parameters that you pass after the SQL in a call like this, the driver can optionally pass that through as text directly to the database and execute it without preparing it. But by default, it's a package that is expecting and is sort of geared towards prepared statements. And you prepare and then execute those statements perhaps multiple times. So the new thing on this slide is db.query, and it returns a row set. But unlike in a lot of other languages, a row set is not a giant blob of memory with all of the rows stuffed into them in arrays or maps or something like that. Again, it's just a cursor. And when it is returned from that row, from that call to db.query, it actually has not fetched any data yet. Potentially the driver has done something database specific under the hood, or if the database starts sending data back, the driver may have already handled some of that data. But there's no data in this rows object. Instead, you use rows.next, and it will return false if there's an error or if it hits the end of file, and exit off the end of the for loop. So you have to call next to advance the cursor to the beginning of the first row. And then you use scan to scan the values out of the row and copy them into destination values, which have to be interfaces or pointers. So hopefully that's clear. And on this slide, I'm collapsing all of the former to a snippet, and I'm showing that after this row, this for loop over the rows iteration is ended, we still need to check for an error. This is kind of an easy thing to overlook, but you may exit off the end of the for loop if you hit the end of the result set and there's no more rows to be processed, or if there was an error. It won't be one of the scan errors because you're handling that within the loop, right? But if there was an error within that rows.next call, you may have exited off the end of the loop. And if so, then the error is kind of deferred, or defer's the wrong word because it's not in the keyword usage of defer, but it is stored in the rows object, and then you can get it out with rows.error and see if you exited the loop because of an error. When you're done, let me switch back to this previous slide here. You see I've got a defer rows.close. You need to close your rows when you're done with them. This is pretty important, and in fact, it's important enough to close this result set, this rows, when you're done with it, that you should try and do your processing. So there have been places where I've gained a lot from restructuring a program to take something out of that loop and get done with all the looping over the rows, close my rows, and then process the data that I've returned, as opposed to, for example, keeping that rows object alive for a while I iterate over it and maybe do some more work inside that loop. You don't want to be paranoid about this, but you definitely want to close that rows object as soon as possible because there's an underlying connection to the database server that is bound to that object and will not be released until you either close it or it gets garbage collected. So you need to take care of that. Otherwise, you're going to start consuming resources, and you'll do things like run your database server out of connections. You'll hit max connections exceeded, for example, in MySQL. And if there is an error, and I'm closing, this close operation is idempotent, so you can do it again and again. And it doesn't hurt anything if it's already been done. When you exit off the end of the next loop, it's already been done for you. So it never hurts to do it again, but you want to make sure that you do that and don't leave that connection sort of bound to something out there. Explicit preparing of statements, the next thing I want to show as a pattern. So here we're using db.prepare. And that returns a statement. And this prepared statement is a little bit funny under the hood. The statement is not bound to a single connection and does not reserve a connection to the database. So you may be used to thinking of a prepared statement. For example, I know the MySQL wire protocol very well. In MySQL, you prepare a statement by sending the skeleton with placeholders, and there's actually a com prepare statement command in the protocol, and it returns back an integer. And the integer is the handle, the identifier of that statement. In the future, when you want to execute that statement, you say com exec statement, you mention the integer, and then you pass the parameters. So at the database level, a prepared statement is actually bound to a single connection. However, in Go's database SQL package, this is not necessarily true. If a statement is prepared against a connection, and then you want to execute it, but the connection that you prepared against it is busy, it'll try and use the connection you prepared against it first. But if it's busy, it'll go ahead and get another connection either from the pool or create a new one, re-prepare the statement, and execute it on that connection. So this is kind of a little bit of magic that's a little bit hidden under the hood. And I'll show you later what some of the consequences of that can be. So you need to kind of be aware of this. But back to the slide, you prepare, you get a prepared statement, you defer statement.close. And then you can statement.query, you can statement.query row. All of these verbs that I talked about that you can execute on the database, you can also execute on the statement. And you can pass, here I'm passing a single parameter in. And then you're iterating over rows as usual and checking errors as usual and so forth. Here, the major difference here is that I'm preparing, instead of a select statement that's going to return rows from the database to me, I'm preparing a statement that is going to it's going to make a change in the database but not return rows. And so you'll notice in the second paragraph of code, you'll notice that there is an exec. I am not querying. So you don't query an insert, you don't query an update. You use an exec for those things. You use an exec for anything that doesn't return rows. And that's actually really important. I have a slide on this a little bit later. Let's see. This is the slide. I should have moved this slide a little earlier. So if you do db.query delete something or other, it's going to return a rows, a result set. Now, the driver and the database SQL package don't know that a delete doesn't return any rows. So they're going to return a rows, which is a cursor as usual, and which keeps one of the connections in the connection pool out of the pool of freely available connections for other things to use, and assigns it to the underscore variable. So the underscore variable is not sort of like, it actually is an assignment to something which will eventually be garbage collected. And that pool, that connection will not be returned to the pool until that thing is garbage collected. And if you know the Go garbage collector, it's not like this happens in, a tenth of a second or something like that. These things have a little bit longer life. And so you can end up with lots and lots of connections being kept out of your pool. And you can easily run over your connection limit to the database again. So you want to use exec, which will return a different type called a result. And that type has a couple of methods on it where you can do things like query what was the number of rows affected and what was the last insert ID and things like that. It should be fairly familiar to you. OK, so things to know. I mentioned there is a connection pool. I think in the original, maybe in the Go 1.0 or 1.1 database SQL documentation, either I didn't read it carefully enough or it may not have said it in any place, but maybe like the word pool might have appeared on the page once. But I missed it, and I missed it for a long time, and I just really did not understand. And the documentation is worth reading very carefully. Every word in that documentation is there for a purpose, and it's generally not repeated. So they will not tell you something in one place, and then for emphasis, tell you elsewhere. So you need to make sure that you pay attention to all of the words in the documentation, which I didn't do in the beginning. So I didn't understand that there was this connection pool. And I was doing a lot of things. I also didn't understand, even though the documentation says it, that there was connections are created and destroyed as needed. So I was doing a lot of things like a whole bunch of sort of retry logic to check if my connection was valid and all of these kinds of things. And by the way, the idiomatic way to detect whether you have an error after you db.open is to do db.ping. It used to be, before ping was added to the package, it used to be that you would do a dummy little query like select one or something like that. But the idiomatic way to do it now is a ping, and that will actually open at least one connection to the database and make that ping and validate that you can really check, you can really connect, like your username and password are correct. Wes Freeman, have you tweeted? Yeah. Okay, thank you. So Wes created a database SQL driver for Neo4j, and he's just tweeted with the GopherCon hashtag about something that bit me a little bit. The default converter, when you are passing parameters into a prepared statement, doesn't let you pass a uint64 that is over 1 left shift 63. So if that high bit is set, then you'll get an error from the database SQL package. And you can work around this yourself with some custom converter or to create a custom type. But I mention this because this is the kind of thing that you won't see unless you're, let's say, using auto-increment primary keys that are big and unsigned in MySQL, which is a 64-bit unsigned integer. And one of these days, that high bit is going to get set to 1, and you're going to start getting errors when you get something out of the database perfectly fine, but you can't put it back in perfectly fine. And I'm not sure what the reason for this is. I don't know if there is a reason that it has to be this way. I would think that it would be better to let the database, if the database can't handle that, if the database doesn't have a type that matches an unsigned 64-bit integer, to let the database itself throw back the connection rather than doing it in database SQL. But that's the way it is, at least for now. By the way, I had a really good talk with Brad Fitzpatrick last night, and I think there's a couple of us in Vivid Cortex who have spent a lot of time on various things to do with database SQL. And it's not I, but one of our guys, Gustavo, really knows what he's doing with database SQL. And we may contribute some stuff. I've kind of had a sort of a guilt thing on my back for a little while. I need to contribute some more documentation. I haven't done that yet, but we might contribute some code changes as well. So some of the things that I'm mentioning here may change in the future if I get off my duff and do anything about it. So you need to be really careful and explicit with your resource consumption when you're dealing with database SQL. So I mentioned this. There's a couple of other things. So obviously idiomatic to defer things like rows.close. So I deferred rows.close in a function that gets into a loop and never exits. It's a function that's intended to run forever. And that was kind of silly, because those defers will never execute. So not only do I have row sets that are being held open forever, and I'm running my database server out of memory, out of connections, but I'm consuming lots and lots of memory, and so my memory consumption as a graph just goes steadily up. And it's a silly mistake that you can make in any package, not just database SQL, but that's one that I made. Another thing is that you can't rely on connection state. So for example, if you do something that mutates the connection state, such as in MySQL, an old PHP habit a lot of people have is set names UTF-8. Or maybe you want to work against a different database, and you do use DB1 or whatever to change your connection's default currently active database. Those things are connection-specific state. And the operations that I've shown you here are not guaranteed to be bound to any single connection. So you could do something like, I don't know, another example would be to set a user-defined variable that you intend to use in subsequent queries. And your subsequent query can run on a different connection. You don't have that state there. So it's kind of, I mean, I was a consultant and helped build a consulting team at Percona for almost 5 years before founding Vivid Cortex. So I saw lots and lots of the kinds of problems that this sort of assumption of state or using state can cause, especially in any kind of a database driver that has a connection pool. So it's something that I instinctively avoid doing anyway. But here, it's really important that you're aware of that, so that you don't do something like, select from my db.table, use other db, select star from table. It may or may not work. You should just fully qualify your table name or something like that. The other thing is that when that connection gets returned to the pool, of course, if you've changed anything about the connection state, it is going to be returned to the pool, and someone else is going to get some kind of dirty state when they get their connection unexpectedly. So the only way that a connection is bound, that you can sort of allocate a connection to something that you're working with and bind it tightly and continue to use the same connection, is in the context of a transaction, which is abbreviated TX. So you get one of those by calling db.begin. Another word to the wise, you should not do db.exec begin, blah, 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 db.exec commit. Those things may happen on completely separate connections. And so you do not want to do that. You want to use begin, which binds a connection to a transaction object, and then you can do transaction.queryRow, transaction.prepare, all these kinds of things can be done on that transaction, and everything is bound to that one connection. And then you want to use transaction.commit to release the connection back into the pool, commit the transaction, and so forth. So there's a couple of things. I just love this picture. Let's pause for a moment. I love GIFs. So there's a couple of things that actually aren't in the documentation, at least not yet, that surprised me a little bit. One is, and I kind of figured this out, I should have just read the source code. It's not that big. But I had my mind in all sorts of things, learning to use Go, and at the time didn't. One is that connections that die or are invalid coming out of the pool or something like that will be thrown away, and operations that tried to use them will be retried 10 times. So here, I've just copy-pasted from the database SQL source code here, and you can see in the middle of this function, db.exec, you can see that there's a loop 10 times over connection failures. So, and this actually turns out that it may not, I was talking with Brad about this last night, this may not work exactly as intended if the driver doesn't return error bad con in all of the intended circumstances. So the way this works with the MySQL driver right now is you can run a really bad query and log into MySQL and do show process list and see that there's some really, oh my goodness, let's kill this really awful abusive query that's running. Kill, and you kill the connection. And the thing comes back, and it will come back 10 times. And there's a few other places where this will happen as well. This is what happens if you get into a really highly concurrent situation and you're not closing your prepared statements. This can also happen when statements are prepared under the hood, for example, in queryRow, and there's not an explicit statement for you to close anyway. So those statements are kind of in a pool of things. And that's fine unless you get really busy in high concurrency. And I think this is probably another design flaw that we may need to analyze a little bit further, but this is something I've only recently become aware of. Null creates a little bit of interestingness because if a value is possibly null, then you can't scan it into, let's say, a string or an integer or something like that. You'll get an error on doing that. So you have to use the provided null types or create your own. At first, I ranted about this because I was doing it wrong and I was creating a lot of sort of boilerplate code and things like that. But if you just want sort of a default 0 value and you don't want to explicitly care whether that value was null or not, you can create, let's say, a null int or a null string. And it's a struct with 2 members. One is whether it's valid and the other is its value. You can just use the value without checking whether it's valid or not if you want to do that, and it may be appropriate in certain circumstances. You can also create custom types through the built-in interfaces. There's a great blog post mentioned in the link at the bottom of the page here. We've done this, for example, to transparently encrypt any sensitive data in the database. So God forbid if anybody should get access to our systems through SQL injection or something like that, they will not be able to see anybody's sensitive information. If they can query the database all they want, and they're going to get binary garbage. And for us, that is completely transparent and beautifully handled by implementing a custom encryption type. And then when we're handling this data that needs to be encrypted or decrypted, we just declare the value that we're scanning into, or the value that's the parameter, to be the encrypted type. It works for JSON blobs that are crammed into a column. It works for gzipping or un-gzipping. It works for lots and lots of things. So here's a bunch of resources. You should follow VividCortex, obviously. Actually, we do try and share interesting things that we find out about Go on there. And again, the database SQL tutorial is very helpful. So that's all. I think I'm out of time now. Thanks.
We do have time for a couple of questions.
Okay.
We got two over here. We'll start right here really quick while you get over there.
Hi. Why do you have to close the rows in order to close the transaction whenever you do a query? And is that the same when you call exec?
So when you call exec, there is no row set, and there's no connection binding to the result. You have to close the rows. I don't know. I mean, I suppose when you iterate off the end of the rows, well, they're already closed. So let me think about this a second, think if it could be done better. I think not. So you have to close them because the connection is still held open, and it's not disassociated from that rows object until you explicitly close it. And you won't know that. The driver and database SQL will have no way to know that you're sort of done fetching rows unless you either explicitly tell it to, or you try and fetch rows and you get the end of file error, in which case it gets closed anyway.
You spoke a lot about MySQL. How transparent are sort of the Postgres driver differences and MySQL driver differences, and how feasible is it to sort of just drop in a different sort of database backend like SQLite or whatever?
Yeah, that's a good question. The question mark parameter placeholders, for example, those are different in different databases. That is not something that the database SQL package interprets. So you'll need to use a different prepared statement syntax for your parameters and things like that. Generally, I've seen, like there are several MySQL drivers, for example. And I didn't know, because I didn't know how to use database SQL at first, I didn't know which of them were better than others. The one that I mentioned in the links here, in my opinion, is very Go idiomatic. I mean, I think it's good enough that it could be included in the standard library if that were appropriate. There are some that do things that are like, we really want to expose this power of the database or something like that. Of course, you can always import the driver directly, and I think that's the appropriate way to get access to those. But in some cases, sort of weird non-database SQL things are exposed to you, and I would encourage not using those because whenever I've seen those done, and I can't speak for all of the drivers out there, but whenever I've seen that done, it looked to me like something that I would prefer to stay away from, that it might cause problems.
Hey, Baron. Would you mind to go back to that slide about prepared statements? I think, at least for me, that there were no labels in the chart. I think it wasn't clear what the issue
the chart
was. Yeah. Would you mind to explain what the chart means?
Okay. Yeah. So this is a chart. This is actually from VividCortex on one of our own servers, DBShard3 here, and this is our prepared statement chart. And we were occasionally in one of our API servers, we were getting the error from the server that we were trying to allocate too many prepared statements. There's a default limit of 16K prepared statements, basically, in MySQL. And so this prepared statement count is steadily increasing. I had to look very carefully through all of our source code and find anywhere that there was a statement that was being created and not deallocated. But there's a couple of places, and I did find one, and that was part of a problem. It was in a very sort of subtle way. But there's also a couple of places where the database SQL package will prepare a statement for you, and then it's kind of lurking there, which is not a problem in most cases, but can be under really high concurrency circumstances. So we were having another problem, completely unrelated, which had to do with our database connection pool. So I can maybe take a moment to explain. In 1.1, there was no control over the connection pool at all. You couldn't see how big the connection pool was or anything like that. In 1.2, there's a function that sets a maximum limit on the number of idle connections in the pool, but does not cap the number of connections in the pool total. If this is a problem for anybody, Gustavo, the guy that I mentioned who's the wizard at VivaCortex and really understands this stuff, has written a package called dbcontrol that we've open sourced. We thought that 1.2 was going to solve some of our problems, but the initial release had a bug, which I'm pretty sure has been fixed since then. And in order to cope with that, we immediately had to roll back to 1.1. It's the only problem we had in the 1.2 upgrade. We had to roll back to 1.1, and in the meantime, we had actually already written this dbcontrol package, which implements a cap on the number of connections in the pool. So those are resources that are available if they're useful to anybody. And did I answer your question, Gustavo? Okay. Right. So, and by the way, totally different Gustavo. Gustavo here for the MongoDB driver, and Gustavo, a guy that works with me. More questions? Are we out?
Oh, that's it.
Okay.
Big round of applause for Brian.